Aloha and welcome to our video on the Earth, Moon, and Sun system. In this video we will describe the movements of the Earth known as rotation, revolution, and precession. We'll explain how the Moon goes through phases, and finally we'll talk about eclipses. So the first motion we're going to talk about is the rotation of the Earth, and that's the spinning of the Earth on its axis. The problem is how do we measure when we've done one complete spin? And we have two different methods. We have a sidereal method, and then we also have a solar method. And the results of both of these are what we call a day. If we look at the sidereal day first, what we're using are distant stars. So if we go outside in the night sky and we look directly above, we'll see a star there. If we go out the next night, we should see that same star in that same location, and that would be a sidereal day. Now the sidereal day runs about 23 hours and 56 minutes. So you notice there's a 4-minute differential, and that means that our stars are going to rise 4 minutes earlier every night. So that's why they change throughout the years, because it's not exactly a perfect sidereal day is 24 hours. Instead, it's 23 hours and 56 minutes. The other way that we can mark a day is we can use that star that's closest to us, and that would be the sun. And what we do is we look at the sun, and when the sun's noon rays are shining directly above a point, and we would mark a day as being when those sun's rays are directly overhead again in the same point. So it takes 24 hours for a solar day to occur. And that's about what we use. It's not always going to be 24 hours, but our average solar day is 24 hours, and that's the time that we use for a day. So both of them, what we're doing is we're looking at a celestial object. In the solar day, it's the case of the sun. In a sidereal day, we're using a distant star, and we're seeing when the light coming from that object is going to be directly overhead and crossing the median in the sky. Now here we are looking at two different things. We're going to talk about the celestial sphere, and that'll help us with revolution. Revolution is the time it takes the Earth to travel once around the sun. So while it's not pictured here, what we're talking about is if we have our sun here in the middle and we draw our orbit of the Earth, if we start at this point here, how long does it take for us to travel around? And the result of this traveling around the sun, the end result is what we call a year, but also it's what gives us our seasons, and we'll talk about those, and we have talked about those in this class already. Now, this here, the celestial sphere that we're showing you, has a couple of interesting things. We see our Earth is here. Directly off the North Pole, we have our North Celestial Pole. Directly south, we'd have our Celestial South Pole. We have two lines in here that we kind of show. We have the Earth's equator, and that is going to be straight out from the equator. So if we took the line, our imaginary line of the equator, and extended it out into space, that would be our equatorial plane, and that's what we call our celestial equator here. However, the sun, because we're tilted in our orbit and we're going around, we have this other line here called the ecliptic, and the ecliptic is going to be the apparent path of the sun. So in June, we notice that the sun's going to be a little higher in the sky. In December, we notice it's a little bit lower in the sky, and that's because it follows the ecliptic, not the equator. So that's one of the reasons why our days are a little bit longer in the summertime, because we're tilted towards the sun. So it's going to make the sun appear to be higher up in the sky. Now, the last type of motion that we want to talk about is precession, and you can see it labeled right over here for you. And what precession is it's kind of the Earth as it's traveling around the sun and it's rotating, it's kind of wobbling like a top does. And because it has that little bit of wobble, the result is that our tilt isn't always going to be 23.5 degrees. It'll kind of back and forth and wobble a little bit. But the net result of that is our North Star that is current won't always be our North Star. It'll kind of wobble back and forth. Back in the early Middle Ages, it was actually a star in the constellation Draco, but we've gone through our precessional rotation, and that's caused it to be our North Star now. Okay, so let's talk about the movements of the moon. First thing I want you to realize is that the rotational period, the time for it takes to spin on its axis, is equal to the revolution period, which is the period of time it takes to go around the Earth. So the result of that is we always see the same side of the moon. However, during a month, we'll notice that different amounts of the moon are going to be lit up by the sun. And that's because it relates to how the Earth and the moon and the sun are all related in position. If we start with a new moon here, what we notice is we have a dark moon. And what we're seeing is because the rays of the sun are striking the side of the moon that is away from the Earth. So because of that, we don't see the brightly lit moon. What we do see is we see the light reflected off the earth onto the moon, so we can still see it in the night sky. Now, as we travel around its revolution, we'll come to the first quarter here. And in the first quarter, if you looked at the moon, it's going to look a little something like this. And what that means is you're going to see half of the moon is going to be lit up and half of it's going to be dark. And the reason for that is because we're at a 90-degree angle with the sun. So because of that, the lit part here is going to show us that half of it's going to be lit up and the other half is going to be dark. We travel another week or so and we get to a full moon. And our full moon here will have the entire moon is going to be full. And that's why we call it a full moon. It's full of light reflecting from the sun. And that's because the shiny side, or the side that's lit up, is going to be facing the earth in its entirety. And if we travel around, we get to the third quarter moon we see over here. Now, there are some other terms that I want you to be familiar with. We have the term here waxing, and waxing is when the moon is getting more and more lit up. What that means is there's more sunshine hitting the moon, so the part of the moon that is lit up from the sun is growing. The opposite of that is going to be waning here. We also see these terms gibbous and crescent. Crescent is going to be when less than half of the moon is lit up by the sun, and gibbous is when it's going to be more than half of the moon is going to be lit up by the sun. So this kind of explains why we have the phases. It's a relationship of the location of the earth and the moon and the sun together, but also some of the terminology you'll see going through there, like a new moon and a waxing moon and first quarter and so on. Okay, and just like the day, how we had two different days that we could measure. Remember, we're measuring based on another object to mark the transition of time. So in a day, we had a sidereal day where we used distant stars, and then we had a solar day where we used the sun, and we run into the same process with a month. If we first look at a sidereal month here, what we're doing is we're measuring with distant stars. So on day 1 of the month, we'll notice that the earth is here, the moon is here, and we line those up, we can go out to some distant star. 27 and a third days later, we'll have the earth and the moon and the star lined up again. So that would be a sidereal month. However, we tend to go more with this synodic month here. And the synodic month is going to line up the earth and the moon and the sun. So you'll see that all three are lined up here. And then 29 and a half days later, we have that same alignment where we will have the earth and the moon and the sun all lined up. And that's a little closer to our traditional accepted 30-day month on a calendar. So we can see how it's going to be a little different every year, and every month we're going to have a little variation. But what we're talking about is we're measuring it based on what? So if we measure it based on the sun, we have a synodic month of 29 and a half days. If we measure it based on a distant star, the sidereal month is going to be 27 and a third days long. All right, so let's talk a little bit about eclipses. A solar eclipse is when the moon is going to travel in between the earth and the sun. And what it's going to do is the moon's going to block out that sun. Because the sun's so far away, we can block out the light that reaches the earth that way. And we're going to end up with a couple different things here. We'll have the umbra, which is the darkest part of the shadow, and we can see it right here. And that's going to leave a line on the earth of transition, of when it's moving, and that's going to be our path of our total solar eclipse. So during a total solar eclipse, that's what you would see here. You would see a little bit of light coming around, peeking around from the moon. This right here in the middle is going to be our moon, and it's going to block out the light from the sun. And we have this path of totality, this path of like where the complete shadow of the moon is going to be hitting the earth. Now, outside of that, we have this penumbra region here. So while it's still a shadow, it's not a complete shadow, but we'll notice that parts of the sun are going to be blocked off from that way as well. So as you look at it, it won't be a complete total solar eclipse, but you'll still see the moon crossing in front of the sun that way. One of the interesting things is in August of 2017, we will have a total solar eclipse travel across the United States, and the path will take it from about Oregon to Georgia. So it'll be the first time that it'll actually come across in a long time that we'll have the opportunity to see it. So a solar eclipse is when the moon travels in between the sun and the earth. Okay, so let's talk about a lunar eclipse. A lunar eclipse is when the moon is going to travel through the shadow cast by the earth. So we can see that the sun is going to shine its rays down here on the earth. And what we'll notice is there's going to be this shadow cast. And we have both, again, the umbra, the complete shadow, and the penumbra, which is kind of like a side shadow, not totally dark. And when the moon travels through this, that's when we get a lunar eclipse. On a total lunar eclipse, that's where the complete portion of the moon is going to travel through this umbra, and it results in this kind of reddish moon color. Sometimes they'll call it a blood moon, and it's just because of the reflective nature of the light coming off of the Earth's atmosphere. It's going to bend a little bit, so kind of like how sunsets are red sky, and that's why it'll kind of shine up in that little reddish color. So a solar eclipse is when we block out the sun. A lunar eclipse is when the moon travels through the shadows of the earth. And those are our two types of eclipses. As always, good luck on your quiz, and we will see you in the next video.